What links jet stream changes to polar vortex events? Imagine a giant river of wind high above your head, rushing around the Earth's poles. That's the jet stream, and it plays a big role in how cold or warm the weather gets from the poles. When the jet stream is strong and steady, it keeps the cold polar air locked near the Arctic. But when it weakens or starts to wobble, things change quickly. The polar vortex, which is a huge area of cold air circling the North or South Pole, can become unstable or even split apart. This allows cold air to spill out into places like North America or Europe, causing very cold weather. The connection between the jet stream and the polar vortex is mainly about temperature differences. When the Arctic is much colder than the mid-latitudes, the jet stream stays strong and smooth. But if the Arctic warms up faster than other areas, the temperature gap shrinks. This makes the jet stream weaker and more wavy. These waves can dip southward, dragging cold air with them. Sometimes, a sudden warming event in the stratosphere, called a sudden stratospheric warming, can cause the polar vortex to weaken or break apart. During these events, temperatures in the upper atmosphere rise rapidly, disrupting the vortex's normal circulation. When the vortex weakens, the jet stream often becomes more distorted. Instead of flowing in a straight line, it starts to bend and dip. These dips, called troughs, allow cold Arctic air to move southward into lower latitudes. This is why some winters see unexpected cold spells from the Arctic. Arctic amplification, which is the faster warming of the polar regions, also plays a role. As the Arctic warms, the temperature difference with the lower latitudes decreases, making the jet stream less stable and more prone to these big swings. So, in simple terms, changes in the jet stream influence the stability of the polar vortex. When the jet stream weakens or becomes wavy, it often leads to the vortex breaking down or shifting. This process allows cold polar air to escape and cause extreme winter weather in places that usually stay warmer. Understanding this link helps meteorologists predict cold outbreaks and better prepare for severe winter storms. It's a fascinating dance between high-altitude winds and polar cold that shapes the weather we experience from the poles.